There are many methods for measuring the shrinkage of cotton fabrics and garments. The most reliable methods use a system that properly prepares the sample for the test, will agitate the goods without tensions or restrictions during wet agitation, and accurately measure the results. The two most adopted test methods around the world are the AATCC Test Method 135, which is titled Dimensional Changes of Fabrics After Home Laundering, and Test Method 150, which is titled Dimensional Changes of Garments After Home Laundering. These procedures are used to predict dimensional changes that occur after home washing and drying. In these methods, a home laundering machine is used to wet out the fabric. This swells the cotton fibers and applies agitation without tension. Wetting out of the fabric without tension is generally enough to allow for elastic shrinkage. However, complete shrinking of the fabric will only occur when drying with mechanical action takes place in the tumble dryer. For complete and reliable shrinkage results, it is recommended to wash and tumble dry at least 3 cycles. Almost all test methods employed by the industry make use of some version of these tests. The materials and equipment needed for this test include the following: an automated washing machine, an automated tumble drying machine, standard laundry detergent, ballast cloth, an indelible ink marking pen, a 15-inch by 15-inch template cutting guide, a ruler or measuring system that yields direct shrinkage numbers, and a weighing balance or scale. The procedure for measuring dimensional changes has 4 steps. These include a preparation step, a testing sequence, an evaluation process, and a data recording process. In the preparation step, samples already properly conditioned must be carefully and consistently handled. Place the 15 by 15-inch square template on the fabric. Align the template's straight edges parallel to the selvages or width edges of the fabric and to the top and bottom edges of the sample. Make sure that the edges of the template are more than 10% from the edges of the sample's dimensions. Mark the outside edges of the template. A total of 3 specimens should be marked if enough fabric is available. The subsequent 2 specimens must be located so that different warp and filling yarns in wovens or different courses and wales in knits are included in the test. If enough fabric is available, then the specimen should be laid out in a diagonal across the width and length of the fabric. If not enough fabric is available, then an L-shaped pattern should be used. Label each specimen with proper identification so it's always read in the length direction. The identification can be a combination of numbers, letters, and symbols. Carefully cut out the specimens to prevent distortion. Mark each specimen with 3 sets of length benchmarks and 3 sets of width benchmarks using a ruler, a stamp, or other suitable device. Make sure the ink used is indelible to laundering. Normally, 10-inch benchmarks are used as they make the mathematics easier to calculate. Some tests call for larger benchmarks, which require the specimen to be larger than 15 inches square. The washing and drying machines in the testing step don't have to be located in a standard conditions laboratory due to the heat and humidity generated in the laundering. Each sample's identification should be logged into a logbook in the laundry. The information should include the ID number, the number of specimens, washing and drying conditions, the cycle instructions, the type of detergent to be used, and any special instructions. The load size should consist of test specimens and enough ballast pieces to make a 4.0-pound dry weight load. Woven and knitted specimens should be washed separately from each other. Exceptions would be in the washing of garments that contain panels of both woven and knitted fabrics. The control should be adjusted to the test specifications. Set the water temperature control to the appropriate setting for the wash and rinse temperatures. Check the wash temperature with a dip thermometer. Temperature control systems are available that are very effective in controlling the washing and rinsing temperatures. Fill the washer to the water level setting required to achieve an 18-gallon level. Set the washer for a 12-minute normal cycle. Add the required amount of standard detergent. Allow sufficient time for the detergent to mix with the water. Next, add the weighed sample load and close the lid. At the end of the wash cycle, Transfer the washed sample load into a dryer. Any loose or tangled thread should be cut off at this time. Next, clean the lint filter. Set the dryer for the timed dry cycle at the 30-minute setting. It may be necessary for some heavy fabrics to tumble dry for a longer period. One of the most important steps in measuring dimensional change is that of specimen handling following drying. Knitted and woven fabrics should be handled differently. Remove knitted specimens from the dryer after the final drying cycle and place flat on a conditioning rack. Remember, knitted fabrics are easily distorted. If knits are hung prior to measuring dimensional change, they will elongate in length, thereby falsifying the data. Remove woven specimens from the dryer after the final drying cycle and hang on the clotheslines of a portable cart. The length direction of each specimen should be hung vertically. The next step is the evaluation or measurement of the change in dimensions. Each specimen must have its benchmarks measured. In knit constructions, the length is the wale direction and the width is the course direction. In woven constructions, the length is called the warp and the width is called the filling. Record the distances or a percentage dimensional change and enter onto a tally sheet or into a spreadsheet. The value should be reported as an average percent dimensional change to the nearest 0.1% for each fabric direction. As mentioned, garments are evaluated for shrinkage with a slightly modified test format. With garments, the determination of dimensional change is based on the location of benchmarks. This is important because garment construction, sewing threads, sewing tensions, and trim may affect the fabric and garment dimensions. Therefore, predetermined and agreed-upon benchmark locations are used. These are covered in detail in AATCC Test Method 150. Knit shirts are evaluated for shrinkage by using benchmarks and, in some cases, with shrinkage squares. In the basic method, a knit shirt is laid on a table and all folds and wrinkles are carefully spread out on the table with the front of the shirt facing up. For shrinkage measurements, the shirt is marked and measured at several locations before and after laundering. The benchmark for length shrinkage is determined by measuring from where the collar is sewn into the shirt at the junction of the shoulder seam. A mark is made at this point, and a tape measure is stretched from this point directly down to the bottom edge of the waist hem. A mark is made at this point, and the length is recorded to the 1/10 of an inch. Multiple and alternate positions may also be marked for the front and the back. The width is measured on the front of the garment just under the armholes. A mark is made 1 inch below the point where the sleeves are sewn into the garment. The width is measured in 1/10 of an inch from one side of the garment to the other. The sleeves are also measured for the length, starting at the top of the sleeve, where it attaches into the shoulder assembly, and moving down to the edge of the sleeve along the top edge. The width of the sleeve is measured across the bottom of the hemmed edge. Another commonly measured dimension is down the shoulder seam from the neck to the sleeve. If the area of the garment allows for it, 18-inch benchmarks may be placed on the front or the back of the shirt, starting above the hem and just below the neck, and at least 1 inch from all edges and seams. If the size of the shirt prohibits an 18-inch mark, then a 10-inch mark can be used. After laundering and conditioning, the shirts are again laid on a table and the same benchmarks are measured again. In order to determine the shrinkage, the length of the washed condition is subtracted from the original length. This difference is divided by the original length, and the result is multiplied by 100 to give the percentage. For example, if the original length is 24 inches for the shoulder at the neck insertion to the bottom of the shirt, and the washed length is 23, then the amount of shrinkage would be 24 minus 23 divided by 24, and the total is multiplied by 100 to give a value of 4.2% length shrinkage. Slacks or pants are measured in a different manner. The most common method is to get a length value from measuring the change in the inseam length. The width shrinkage is determined by measuring the waistband. For the length, the pants are spread on the table without distorting the garment. A mark is made at the top of the inseam where the pant leg joins the crotch. The length is measured from this point down to the bottom of the inseam. Another technique for measuring length shrinkage on pants is to make 18-inch bench marks down either pant leg on both the front and the back. The waistband is measured for width by carefully spreading the waistband to eliminate folds. A tape measure is placed at one edge and spread across the waistband until it comes to the other edge. Again, the width is recorded. After laundering, all the bench marks are measured again, and the shrinkage values are calculated using the same method as with the shirts.